Rational functions, rate of change. Here we have about 6-7 thinking questions for you to do. Now these are properly selected so that you get insight to rate of change. You may have to watch the videos a couple of times to really get insight to the solution. You may prefer to, I should say. Okay, the function here is f of x equals to 6x divided by x minus 2. Determine the coordinates, x coordinates, for a point xy where x is between 3 and 5 and the slope of the tangent line at that point equals slope of the secant line joining 318 and 510. Correct? So basically in this problem we have to find only the x coordinate, not x and y, right? Just the x coordinate on this graph of this function 6x divided by x minus 2, where slope of the tangent line is equal to slope when you join these 2 points. So that is the problem. Now slope of these 2 points is very easy to find. We can find slope of these 2 points by doing rise over run, that is y2 minus y1 over x2 minus x1, and that, let's take this as y2. This is bigger value. I just want to take this on y2. It could be anything, right? So y2 minus y1 means 18 minus 10 divided by 3 minus 5. Important thing is that we have to maintain the order. If you select this as the first and that is the second point, it will be 10 minus 18 divided by 5 minus 3. Either way, you get the same result, right? So now 18 minus 10 is 8 and 3 minus 5 is minus 2. With that, you get minus 4 as the slope of the line joining these 2 points. So we have done. Now we know at least what slope is required, right? Now to find the slope of a point, to find a slope of tangent line that has slope of minus 4 and it is tangent to the function 6x divided by x minus 2, we'll take a general point because we really don't know what that point is, right? The whole idea is to find that point. So we'll use difference quotient method here to find that point where the slope is minus 4. So we'll do instantaneous rate of change at a point and let that point be A, for example, right? So in that case, if the point is A, then we can write this expression as instantaneous rate of change. I am using instantaneous rate of change, right? So that is my short form of instantaneous rate of change. At times I may use this symbol itself showing instantaneous rate of change, right? So instantaneous rate of change at a point A, for example, will be f of a plus h minus f of a divided by a plus h minus a, where h is a very, very small number, right? So for some of you who know the concept of limit, for them I'm writing here limit h approaches 0. That means h is very, very small. And for those of you who have not done this part, that limit h approaches 0, let me write here that h is very, very small, like as compared to 1. For example, you can put value of h as 0.001. Okay, so 0.001 is kind of very small when we are comparing numbers like 1, 2, 3, 4, right? 1,000th of it, right? So that is how we are going to look at it. But in my solution, I'll use the term limit h approaches 0. Okay. Now, what is a of h? A of h is, you replace this x with a plus h, right, in your formula. So you get a of h. So f a of h is 6 times, instead of x I'm writing a plus h, right? Over, instead of x, I am writing a plus h minus 2, correct? That is fa of h, right? Minus f of a. F of a is, a means instead of x, I will write a. So 6a over a minus 2, correct? And okay, so let me switch my definition. Instead of writing limit every time, I will write here once for all, where h is very, very small. So I'm writing here h is approaching 0, right? H is very small, right? Instead of writing limit, h approaches 0 all the time. Remember, h is very, very small. Okay, it is approaching 0. It is not 0, right? Okay, divided by a plus h minus a will give me only h. Is that okay? So that is what I get. Strictly speaking, I should have written like this: limit h approaching 0, right? Okay. Okay, let it be so. Now let's try to solve this kind of a fraction. So I need more space here, so I'm starting from this place. Equals to. So what will happen is we'll take common denominator of a plus h minus 2 times a minus h. Okay. So when you take that as a common denominator, that comes in here, and that gets cross multiplied with this, and this gets cross multiplied by that. So I'm using all these things and writing down here, right? So let me write limit h approaches 0, right? Those of you who are scared of this, just forget about it and think h is very small. Okay, now let me cross multiply, and I get 6 times a plus h times a minus h. How do you get a minus h here? This was x a minus 2, so this is wrong. This is a minus 2, right? A minus 2, correct? Because we just replaced x with a in the numerator. And there you get 6a times a plus h minus 2. A plus h minus 2, right? So this. And in the denominator, you have h times this factor, which is a plus h minus 2, right? A plus h minus 2 times a minus 2. Okay? A minus 2. Correct. So that is what you get. Now what we need to do is we can just multiply all these terms and simplify. Correct? So since we have 6 and 6 common, we can just take 6 outside. Right? We need not multiply by 6 at all. We'll just take 6 outside. So let me write, like, change the ink so it's getting mixed up. So we'll write limit h approaches 0, and first let me draw a big line here. So 6, I'm not multiplying everything by 6, rather I'm writing 6 outside. I'm multiplying rest of the terms. So we get a square, and a times minus 2 is minus 2a. H times a is ah, and minus 2h, minus 2h. That is these terms, right? And here when I do, I get a square, which is with minus sign, right? So I get minus a square, and then minus ah, and then I have, this is minus, and that is plus 2a. So we get plus 2a, and that's how we have. And the denominator, we get h times a plus h minus 2 times a minus 2. Okay. So let me shift this page a bit on this side so that you can see exactly what's going on here, right? Okay, that's where it is. Now as you can see, we can simplify this. Many of our terms get cancelled. I'll show you how. A square minus a square is 0. Cancelling means I'm just showing you minus 0, right? And then, in fact, these terms which were at the end will all cancel out. Let's start from the right side then. 2a plus and minus 2a becomes 0, right? Ah minus and plus ah becomes 0, correct? You are left with this, correct? So that is what you're left with, and we can say this is equals to limit of h approaches 0, and in the numerator we have minus 2h, right? 6 times minus 2h, which is minus 12h, right? So we get minus 12h in the numerator, and in the denominator you have h times a plus h minus 2 times a minus 2. Is that okay? Now here you will find that h is common factor, so h divided by h is 1, correct? So now we cancelled out this. If h is very, very small approaching 0, that's what we meant by this nomenclature, limit h approaches 0, right? H is very, very small. So we can write this as minus 12 over a minus 2, right? So which is a minus 2 whole square. Is that okay? So that is what we get as instantaneous rate of change at a point A. We don't know what that point is, but at any point in general A, that is the instantaneous rate of change for our given function f of x equals to 6x over x minus 2, correct? Now what do we need? We need slope of the tangent to be equal to this slope, which is minus 4. So we can always equate this to minus 4. Do you understand? So if I equate this to minus 4, then we can find what value of a will satisfy this equation, correct? Okay. So that calculation now we will do and find what is the value of a. Before going there, I would like you to make a note of this, and then I'm putting this in a red box. Reason is very simple, because I'm doing series of questions here which are kind of related, right? So I'll have another question related to this. But let me write here first what we have already achieved, and that is the rate of change here. That means instantaneous rate of change for this given function is equal to minus 12 over a minus 2 whole square, right? This is what we have got. So we'll discuss this a bit more later. First, let me complete this solution and then find the value of a. So let me push this a bit more ahead. So we can now cross multiply and say, well, minus 12 divided by minus 4 is equals to a minus 2 whole square, right? Now minus 12 divided by minus 4 is 3, right? So we get a minus 2 whole square is equals to 3, correct? So that is what we have. Now we can simplify this. That means we take square root both sides, and that implies that a minus 2 equals to square root of 3. But when we do square root of 3, we get plus and minus, correct? Plus and minus whenever you do square root, plus and minus 3. And that gives you the value of a. And a is, when you bring 2 this side, we get 2 plus minus square root of 3. So in fact there are 2 points on this curve where the slope of the tangent is going to be same as you get while joining these 2 points, right? So now we can write down our answer. And that is the x coordinates of the points are, so we say x coordinates only, right? If the question is to find the coordinates, you have to plug in this x value here and find y f of x, right? That is a big exercise which you should do on your own, right? So x coordinates are, so one of them could be 2 plus square root 3, right? You can write separately, or the other will be 2 minus square root 3, right? So these are the points where instantaneous rate of change for this given function will be same as a secant line joining points 318 and 510, correct? So that is the way to do it. I know it's like I squeezed in a lot of information into a small space, and that's the whole idea, to add the most of the information right there in a small bit of space, right? Now I hope you understand all this. What I've done is a simple mathematical manipulation to get the answer. Now from this question we can ask you a couple of more questions, right? One question could be, is there any point on this function where the function has positive slope. There is no point, because the instantaneous rate of change at every point we found is minus 12 over a minus 2 whole square, right? So you can see from here that every point the slope is going to be negative, because denominator will always be positive. It is a square, right? So minus 12 divided by something which is positive will always give you negative answer, right? That means slope at any point on function fx, 6x divided by x minus 2, is going to be negative, correct? Now another question we can ask here is, can you have a point on this function where the slope is 0? Well, again the answer is no. It has to be negative, right? It cannot be 0. Well, but when a approaches a very, very large number, like we say positive or negative infinity, right? Then the slope approaches 0. It will never be 0, but it will approach 0. So that is another thinking and communication question which could be asked based on this particular problem. So I hope you appreciate and see this problem in many different ways, so that you could answer your test problem in the best possible way. Thank you and all the best.